workshop here the last couple of days. Sue's another one of the old timers that's been around since the beginning, been very engaged and very helpful in bridging the gap between the forecasting world and the power systems world. So thank you, Sue, for that. And Matt Sugar, many of you may know Matt from his earlier days when he was a consultant working in the wind area, more recently as a commissioner, and now back into the consulting world, working with us here at ESIG. So I'm going to turn it over to Sue, let her introduce the session and the speakers, and look forward to a very great discussion. So thank you, Sue.
Okay, thank you, Charlie. Is this on? Okay, great. So it's been a really exciting couple days, and I love coming to these meetings. I always learn so much. And one of the things that hit me this year is the huge load growth that some of the ISO TSOs are experiencing right now, and especially things like data centers and the manufacturing to support them and all the issues that brings with them. At the same time that we're electrifying the transportation sector, the building sector, and moving to net zero, which means a lot more renewable energy, variable renewable energy dependent on the weather, what that means in terms of extremes in real time, planning for those extremes in the future. Wow, isn't it getting complicated? I don't think any of us can understand all the aspects that go into it. But as a collective, we do have the right people in the room to understand each of the pieces and to talk about it in ways where we can make a difference and try to do this transition right. So we're going to start with two talks, one from the market and industry, one from the meteorology perspective, and then we're going to have a panel of folks who have spoken at this meeting, who really understand their aspect at a deep level, give their thoughts on the challenges and opportunities for how we can make this better. So we're going to begin with Paul, and Paul Sotkiewicz, is president of EQ Policy Associates. He will say his name himself. And he's going to give a perspective from the industry side, understanding the markets and what he heard and sees as challenges and opportunities.
Thanks for the introduction, Sue. Good morning, everybody. I'm Paul Sotkiewicz, president and founder of EQ Policy Associates. Some of you may know me from my past lifetime as a chief economist at PJM, where I kind of touched everything from markets to planning to operations. So what I kind of want to do here is give some closing thoughts here. But I think I want to just start with the fundamentals very quickly. This is nothing surprising. I'm not going to spend too much time talking about it, is that regardless of the weather, regardless of the configuration of generation that we have on the system, wind, solar, storage, hydro, geothermal, whatever new technology we haven't thought of yet, the principles of system operation will always remain. We have to maintain energy balance, frequency response and regulation in the short term, six second AGC base points, maintaining contingency reserves. Maybe we have to hold additional reserves for uncertainty. We have to maintain transmission security. None of this goes away. None of it goes away. And I think we forget, and not maybe here in this room, but policymakers forget. They look at the levelized cost of energy and wonder why we're not building more solar and wind. Why don't we get rid of all the dispatchable resources? On a cost basis, it looks great. Charlie put those slides up at the very beginning of the workshop this week. But that's not how the world works. We have to maintain energy balance all the time. So I think that's the first thing that we need to keep in mind. And I think one of the things that we need to find a way to do, we're involved here in the technical work, but we have to somehow find a way to communicate the technical work to the policymakers, to the legislators, to the NGOs who are pushing this, who don't understand this. And I think that's key. The other thing I'm going to really get to, and I think is sort of the underlying theme, and I think almost the session yesterday afternoon where we heard from California ISO, we heard from the Australian market operator, SPP, MESO, looking at uncertainties a few days out, maybe a week out, maybe 2 weeks out. There's a lot of uncertainty. And I can tell you from experience working down on the floor with dispatchers, they hate uncertainty. They can't stand it. They're like, how can I make this more certain? Well, the simple fact is we have to embrace this. It's with us whether we like it or not. We have to embrace it and understand it. Learn to love it because it's not going away. Because it impacts the load forecast, it impacts forecasts of solar and wind output, what we can do with storage, not just storage, but thinking about the discharge and charging cycles. Short-term batteries, if we have a Dunkelflaute, I may discharge all my batteries. How am I going to charge them? We've seen this with pumped storage hydro in some systems. Hydro-Quebec and BC Hydro are now seasonally looking at how to optimize their exports of hydro, BC Hydro here in the west, and Hydro-Quebec in the east, using their systems as a large battery for the continent. We need to start thinking about these things. Then we have the other load forecast uncertainties that we've seen. We saw with Winter Storm Elliott, a lot of systems who shall remain nameless blew their load forecast by more than 10%. We also have to start considering outages, planned outages, maintenance outages. How do we account for that? And I won't get too deep down in the weeds, but Alberta, the Alberta system, had a load shed event on April 5th. In the middle of maintenance season, weather was mild. What happened? Ton of stuff out for maintenance. The wind and solar forecast didn't come in, didn't have all that stuff. And then you had a unit trip. All of a sudden you go from just barely being at the edge to an EEA3 and shedding load in a heartbeat. Understanding the fuel market dynamics, gas-electric coordination, which is something that didn't come up too much. So I'm going to be a little provocative here. And this is my idea. We'll call it Dr. Paul's law of conservation of risk. Risk can neither be created nor destroyed. You can't. It's always there, whether we know it or not. It's all around us. Now, you can transform that risk in different ways. You can transform it from event risk into a monetary risk or monetary value. You could transform it from a monetary value into an event risk. And the thing here, if I'm thinking about power systems operation and control, is the idea that if we're thinking about this, do we take actions that cost money to prevent involuntary load shed or something worse? Or do we let it ride and just take the chance? I don't want to spend the money because, and I've heard this from system operators, I don't want the markets guys accusing me of creating uplift and then the markets guys go crazy and then the lights go out. There's risk there. How do we choose to transform it? Then the other thing is, what about knowing what the risk is? I had to throw in Donald Rumsfeld here. He's not my favorite person in the world, for the record, but there are known unknowns and unknown unknowns. And it's true. There's things out there that we haven't thought about. Did anybody really think about Winter Storm Uri when it happened? Did anybody think about that? Some people had. Hey, I've seen the Met data. I can look at 1989 and go, it was just as cold. It was just as bad. But there are a lot of different things that changed. And by the way, we as human beings have really, really short-term memories. We forget because it's too hard to remember. Also, risk can be transferred from one party to another, knowingly or unknowingly. So if we think about this from an operations perspective, if we're making decisions to commit units, we're transferring risk from reliability into money, but it's being then put on generators and loads in different ways. If we don't, with uncertainty, commit resources when we think we ought to, and we let it ride, we're now transferring reliability risk to the generators and loads, and they don't know it. As system operators, that's a problem. We need to make this transparent somehow, and I'm really heartened to see the work that's being done in places like MESO and SPP, as I mentioned earlier. And this is where the melding of weather and power systems modeling come into play. So just very quick, what I've done is just created a very quick and dirty timeline while I was sitting here during the first session. And let's think about starting from real-time operations. Real-time operations, there really is no risk and uncertainty. We've got the realizations. We've got the realization of weather. We've got the realization of the load forecast, whether it was right or wrong. We have the realization of generator outages. Go out to the day ahead market. And that's where day ahead unit commitments are made. We're still looking at uncertainty. Now we have to make decisions. But how do we make those decisions? We need information from operations planning. Go back 2 or 3 days into 2 weeks. What does operations planning need to do? And this is where I'm really heartened to see. Looking at the range of weather forecasts, range of renewable outputs, generator outages, load forecast errors, planned and maintenance outages that have already been approved and taken. Come up with an operating plan that's going to minimize some of these reliability risks potentially. Then we go out even further. There's another range, I think, of operations planning. By the way, this is not written in stone, for the record. This is just sort of my cut at it. Is that, oh, we can look at ranges of weather forecasts, seasonal weather forecasts, and we can refine outage schedules to match that. Some of the worst issues that we had when I was at PJM were in the fall shoulder periods during maintenance season, where we had generation and transmission out. And if we were able to have some visibility and think, okay, maybe we shouldn't do that, maybe we should recall some of these things, we could have avoided a lot of heartache. And then we can go out even further. Let's say 3 months out to a year. Long-term seasonal forecasts. Start managing planned and maintenance outages. When do you start approving those outages? For what times of year do you plan those outages? We're shoving them all into the shoulder periods, creating risk in the shoulder periods that heretofore haven't really existed. And it's only going to get worse. And then there's long-term planning, and that's a completely different beast. So where are we at today? So you'll see that I put a nice little marker here. You are here. This is what we've been talking about, I think, a lot. And I think the last afternoon session that we had yesterday on this was, to me, the linchpin of everything, the culmination of the start of the workshop to everything that we've seen, in my mind. And that is thinking about looking at the range of weather forecasts, the probability distributions of outcomes, then looking at wind and solar output, looking at what's going to happen to generator outages, the load forecast error, and so on. And coming up, stacking that up, combining it all, coming up with an assessment of risk. How do we deal with that? Maybe we need to commit additional resources. Maybe we need different reserve products. That's where we're just starting. But then we need to do the following. We need to translate that up to what's going to happen in unit commitment. And that's where the rubber meets the road. Unfortunately, operators want certainty. They also don't want to get yelled at by their executives or the markets guys for incurring extra costs. They're going to be really conservative and extra cautious one way or another. I can tell you from firsthand experience, I wear the scars of that during the 2014 polar vortex. Long weekend, operators didn't know what to do. I'm on the floor. I'm one of the few people that understood the gas industry, not trying to be arrogant. They're like, what do we do? I'm looking at a Sunday night, Monday morning, Tuesday morning ramp. Long holiday weekend. What do I do? Buy the gas and we'll sort it out later. The worst thing we can have happen is have the lights go out. And I'm an economist, for God's sake. I'm not looking at this from a monetary standpoint anymore. This is about a health and safety issue. And we need to think about how to incorporate those things. So the problem is that we're not there yet. We have this piece now. We're starting to get this piece. But how do we translate it here into day-ahead markets and day-ahead unit commitment? That's where the rubber meets the road. That's the challenge. That's one of the many challenges. And then I'm going to conclude here. I know I'm a little bit over time, so I apologize. Is what are the challenges going forward? And I'm not going to talk about technical challenges. This group, we're perfectly capable of handling those challenges. The issues are psychological. They're institutional. Change is hard. And we as human beings often resist change. Institutions really resist change. If you just go back to where I was at here, this piece right here, that's an institutional fear of change. Translating the work that's being done now, the good work that's being done, up into getting this into the marketplace so that it's all transparent. That's hard. But we have to change. If we don't change, we're not going to adapt, and I like to say it's not going to end well, but it's going to be a disaster. The other problem is we're working in cylinders of excellence. We're all experts in what we do. We have meteorologists, engineers, system operators. I'm glad you like that, Justin. But we live in cylinders of excellence, silos. We don't get out of our silos. We're like prairie dogs. Occasionally we'll poke our head out of the hole and look around. But we need to do more of that. We need more meetings like this. And we actually need to have sessions that are not concurrent, where we're all split up and going, well, which session do I attend? I think we need to have sessions where there are large sessions like this, where we have a combination of power systems people, meteorologists, modelers, and we all try to bring this together. I mean, that's part of the challenge. That's what we can do as ESIG. And then once we do that, maybe we can learn how to communicate that out to the other people that are making the decisions. We're not making the decisions. We're just informing those decisions. But we're scientists. We're data-driven. We're empirically driven. The people who are making decisions aren't that. They're emotionally driven. They're politically driven. We need to find how to communicate what's important that we see in a language they understand. And so I'll just leave with that. Thank you very much, and I apologize for going over time.
Food for thought there, Paul. Thank you. Second up is John Zack of MESO, who is in the meteorology space and has been working on energy issues for several decades now, really since all of these meetings started. So John, love to hear your thoughts.
That better? Yeah, okay. All right, well, you missed some of the better stuff from the talk here. So I'm going to talk about two different timescales and some comments, and then a little bit of a general comment, a societal overview issue that I walked away with after 2.5 days here this week. So first, on the planning timescale, we started out Tuesday morning with a 4-hour tutorial session on weather data sets for power system planning. And in some sense, this was an outgrowth of a report done by ESAFE, led by Justin Sharp and team, on the various issues associated with the production and use of these data sets. And the tutorial session really highlighted where we are, with those data sets, which form the core of what goes into many of these power system planning studies. And there are many historical and future-looking data sets, and they have vastly different attributes, right? And they're available out there. In many cases, you can go out on the web, the internet, and download them and start working with them, right? And arguably, almost all have serious issues for most of the primary power system planning applications. So not to say they don't have usefulness, but you can point to serious issues such as the resolution, the period of record, the relationship between different variables in them, right? So which ones should you use for your application, right? And there's really no meaningful guidance on the relative suitability of the data sets for specific applications. So a user goes out there and, which one do I use and why should I pick that one? Well, actually, that question is rarely asked and answered, right? And you look at what users do, and to some extent, we haven't really known what users do and how they make decisions in using these data sets. And NREL has recently conducted a survey on user perspectives, needs, and practices, and you can still participate in that. And you go back to Luke Levin's tutorial slides, there's a link, and certainly that would help the community in terms of understanding, what people do with these data sets and how they view them, how they evaluate them, right? But the question is, how do people decide what to use? What are the criteria? And the bottom line from what we know is it's mostly based on what the institution they're with uses, how easy it is to download. Rarely do you look at the attributes of that data set and how they match what your objective is, right? And that's the big problem here. And that was very clear in the discussion during and after the tutorial. So thoughts for the future. Well, Justin earlier this morning brought up the concept, well, maybe we need to create a data set specifically designed for power system planning, right? To address the important attributes that are required to get planning studies that are consistent and forward-looking, right? What do we need to do that, or do we need standards for data set intercomparison to facilitate decision making? If we had standards on the key attributes, and these key attributes are undoubtedly user case dependent, right? Different applications, different use case, well, different attributes are important in the data sets, right? But we have no set of metrics that you can turn to and say, well, data set A on this metric is better than B, or metrics A, B, and C, and those attributes, which are important for my application. We don't have that. So, I mean, an alternate view is if we can establish some standard set of reference metrics and for the primary use cases, maybe that would motivate the community at large to push forward to create data sets that optimize those attributes. And maybe the end result is that we need to put the resources into a data set that would be created specifically for these purposes. So, I mean, there's many questions here, but the overarching one is we do need quality data sets, and we don't have that now to address a wide range of planning objectives. Okay, so I think that's what came out of the tutorial, and that is going to be an important thing that we have to address as we go forward. And how are we going to meet the need for these planning data sets? And an underlying issue here is, what are the relative merits on different planning horizons of using the historical data and extrapolating the trends forward versus using the climate model simulation? We know the climate model simulations are good at certain things, and they're not good at other things at all, right? In terms of some of the variability and the intervariable relationships of the scale of those models, and how they're formulated primarily for global change. That's why these models were created, not to simulate regional or sub-regional variability. And people try to use statistical and dynamical downscaling. But at what point do we switch from the historical data sets we have now, right, and extrapolating that forward 10, 15, 20 years? And at some point, when climate models are the best solution, right? And I don't think we've established, again, that falls under the heading of guidance. So the takeaway here is we need better guidance for the users of these data sets, and what are the attributes that are important, and how does each data set measure up on those attributes that are important for your application, not generic. So now I'm going to switch gears a little bit and talk about the other time scale, which is at short-term time scale of hours and days and maybe a week ahead. And we heard a lot of presentations in different aspects of that short-term planning, right? Operational planning. And one of the most exciting things was probabilistic forecast. And there's an impressive effort, and there was a session yesterday, and many of the major ISOs were presented their development of tools and procedures to use probabilistic forecast and probabilistic information to manage generation and load uncertainty, right? And 17 years ago, we talked about the value of using probabilistic information to manage uncertainty, right? And it's been very slow to evolve. And it was very exciting to hear that session that now, tools are being developed. People are considering, how do I model uncertainty, right? And how do I use information that will give me a chance to manage that in a very dynamic way from day to day, right? After listening to those presentations, there were two ideas that crossed my mind of where we go from here, and those were related to optimizing that probabilistic information. And many of those techniques that are being developed are using only historical error distributions. So they're not very sensitive to the variations in uncertainty from one day to another, right? And that's where the use of ensembles come in, right? Weather model ensembles or even statistical model ensembles, provide you with case-to-case variation in the uncertainty, and some estimate of that. But you have to look at how those ensembles are calibrated. Typically, if you use a small ensemble or an ensemble from one model, you're going to be under dispersive, meaning you don't actually capture all the uncertainty that there is. And that's where calibration comes in. This has long been known, but there's a tendency for users to use the raw ensembles without considering that you're only getting part of that spectrum. So I think it's going to be important going forward that we look at the overall uncertainty and how we calibrate from our estimates back to the true uncertainty, right? So, and there hasn't been a lot of attention given to the evaluation of the attributes in a probabilistic forecast. Most of it has been on the reliability. Does the outcome frequency match the forecasted probability? But the evaluation of probabilistic forecast goes far beyond that to compare one to another. Now, another exciting area that we had was the AI machine learning, and the rapidly advancing AI machine learning tools for energy forecasting problems at a broad range of timescales. The results were most impressive on the timescales where NWP historically has not been especially effective, on the intra-hour, minute timescale and the seasonal time frame. We saw presentations yesterday where there was tremendous progress in both of those areas, and those are not areas where NWP has been strong. But what is the future? Well, AI and ML really continue to provide large increases, and they're going to be constrained by the data available. If you don't have data available to provide input to map out the relationships, then you're not going to be able to get much more out of the AI. I mean, they're dependent on what relationships there are that you can find. And if you don't have that data, you're not going to be able to move ahead. And the big thing that we're seeing now is the emerging trend to AI machine learning-based weather prediction as an alternative to NWP. And that has exciting possibilities, and it remains to be seen, how that's going to affect the long-term and the short-term applications in the power system. Right, so a couple of other points, I know we're near the end of my time here, is where to put the forecast improvement effort. Dave Larson of EFRI commented, reducing average error is not enough. And we've talked about that for many years, that improvement in forecast performance doesn't uniformly provide value, right? So there are certain situations or applications where there's more value than others, right? The classic comment is 80 or 90% of the forecast value occurs in 5 or 10% of the cases. So, we need metrics that express that, and undoubtedly it's use case dependence, but I think we need to look at where the value is so we can focus on those areas that are going to provide the most value with all the tools we have available. And then the other thing that struck me is that there's changing relationships of net variables to power system variability. And we see a number of examples of that in hybrid power plants. It smooth out a lot of the small scale variability. It changes the forecast problem. How will EV charging be weather dependent? We know that EVs use a lot more energy, deplete their battery more in cold weather. Right, so how is that going to impact the grid when you go back home at night and now your battery is more depleted than average? How will that change the load? Debbie Liu presented a talk that Nick Miller had put together about dual mode heat pump on the Prince Edward Island and how heat pumps can go into a mode of resistance heating that use much more energy when it falls below a certain temperature than the standard operation. So now you have a different type of temperature sensitivity. So what else are we not thinking about? How is the relationship between the meteorological variables and the power system variability going to change as we go forward? So I'll conclude with the bigger social perspective that struck me here. We have estimates that we need about a 4-time increase in the current renewable installation rate to transition the current electric system to the 2050 net zero greenhouse goals emission standards. Yet we saw here that we see the load growth is poised to dramatically accelerate. And part of this represents electrification of buildings, heat pumps for heating, transportation, EVs. So you're reducing non-electric emissions. So okay, we understand that. But it also appears that a substantial amount is increased use of energy, like data centers, right? That now and what are we doing with the data centers? I mean, are we using them to profile us so we can get more specific ads on our phone that are targeted to what we should buy, right? Somebody decided, okay, and we're using a tremendous amount of energy to develop data, right, for that purpose, or for watching videos, no matter where we are in the world. We can now use the device and download videos via streaming process. So from a societal point of view, can we achieve a transition when we're constantly moving the goalposts of more and more demand for power because we find more and more ways to use power? Some of them may have minimal or marginal benefit, right? I mean, it might be fun, but is this really what to do in a case where we are moving towards what the climate issue, where we need to make progress at reducing the CO2 content or greenhouse gas content in the atmosphere? So I mean, I think there's a societal issue here. There's some discussion as to how do we balance energy use growth with that transition. Remember, a lot of these data centers are contracting with renewable energy suppliers, so they're green data centers, but they're competing for labor, for resources with the other part that's trying to make the transition from the fossil fuels to the more renewable oriented electric system. So, I mean, it's not free, even though maybe that's how it's advertised. You're competing in terms of capital and other resources. So if you're using developed data centers, you're not transitioning the rest of the system as rapidly. So sorry for going over, but those are my thoughts.
Great, thanks very much, John. 2 excellent opening presentations. We'd like to bring our panelists up now. And as they're coming up, I'll just introduce who we have up here in addition to Paul and John. We have Arnie Olson, Senior Partner of Energy and Environmental Economics, Pascal Stork, Head of Technology at Vaisala, Eric Ela, Technical Executive Program Manager at EPRI, Jim Wilczek, Research Meteorologist at NOAA, Andrew Ackman, Principal Scientist at AMO, Justin Sharp, Research Leader at EPRI, and Jennifer Newman, Vice President of Atmospheric Science and Research at RE Surety. So it's a great group. We really want to hear from our panelists going forward here about what you heard over the last couple of days, what you see as key challenges, offer a few insights from your perspective, and then we'd like to build this conversation with the audience. So again, we'd like to hear from each of the panelists that just joined us, and then we'll turn to the audience as well. So why don't we just start right down the line?
Okay, thank you very much. Cognizant of the time, and I think we're kind of running a bit behind here. I'm going to be very brief, but I think that one of the main points that I heard a lot about this morning through several great presentations was this issue of compound extreme events and the risks and that those pose to the system and the uncertainty associated with them. And so I just wrote down a couple of topics that I think are related to this entire question of compound extreme events. I think if you put on a scale, you know, on one side, what do we know about compound extreme events, and what is it that we don't know? I think what we don't know far weighs more than what we do know. Basic statistics, we can start out there. What's the frequency? What's the duration of them? Their intensity? You know, if you go and you look at just what is the frequency of occurrence of a wind drought by itself, depending on what metric you use, you will find they occur pretty frequently. If you do the same for solar, they occur pretty frequently. If you look at wind and solar combined, much less frequently. And then if you look at the combination of wind plus solar plus high loads, that's even a rarer event. And so the question is, how long of a data set do you need in order to be able to really understand the full statistics of these compound extreme events? Other things that we don't know about them is how do they vary by region? Certainly a compound extreme event in ERCOT is probably going to be very different than on the Quebec interconnect. How well can we forecast these compound extreme events? I think that's a wide open question. We don't know. AI models, can they be trained in order to be able to focus on making good predictions of these compound extreme events? Maybe. What kind of data sets, however, do we need in order to be able to train them? And are those data sets long enough? Do they contain enough of these events? What impact do climate modes of variability have on these compound extreme events? You know, we know that MESO can have a pretty big impact on renewable energy generation. Does MESO have impacts on these extreme events? Climate change itself. You know, we know it's obvious that climate change is impacting load by a tremendous amount. Will climate change also impact the joint probability of a wind drought and a solar drought and a high load event? We don't know. I think finally, then I would just like to end with some potential solutions. So these are transmission, storage. I think have a profound impact on all three of those. And the other parts of the solution are flexible load and potentially also just maintaining some natural gas backup on the system in order to be able to deal with them. Can we design a system where maybe it's only 95% renewable energy and we have might be 1 or 2 days a year where you need to be almost 100% natural gas, where you don't have wind or solar. So those are some thoughts. Thank you.
Great. It's been a really impressive few days, and my notebook is filled with notes, and I've run out of ink. I guess perspective I probably just wanted to add to this final panel is probably around data and AI. This is a bit more of a general kind of tech space rather than really an industry space. That we're seeing this everywhere. It's a extremely buzzy and hyped up sort of just sort of industry that's coming out here. And You know, and I think what's also really driving that is that we've never been empowered with so much access to so much data and technology, and we've been able to adopt AI and machine learning methods so much more efficiently, you know, at a pace that I've never really seen before, and it's only going to increase. I recall last year coming to this conference in Denver, and there being quite a few conversations I've had about like, how do we start doing machine learning? How do we start doing this? And how do we just like even kind of get the ball rolling? And this year I've come back and it's 1 year later and everyone's applying it. Everyone's, you know, adopting it, and, you know, it's coming into the climate space and the weather, the meteorological space, into the operations planning. I think everyone's kind of past that first hurdle and is now really trying to think about how to apply it. I guess the biggest risk with that is that it's to ensure that it's not a solution looking for a problem. It's not, let's just kind of throw everything at it and figure out how to kind of, let's hope that it's just going to work and solve our problems. So just like anything, it's really important to be kind of building out tools and development processes that are actually tailored to solve specific problems. And what that also requires is not only kind of, you know, adequate resources, computing, and also in-house capabilities to actually build out those solutions, but also collaboration and coordination with different stakeholders and end users, and really just ensure that what you're building out is really relevant. So I have lots of other notes around uncertainties and other kind of efforts that can be put in place, but I think that plenty of people are going to be talking about that, so I'll kind of pass it along there.
So one thing that's really struck me this week is just the incorporation of probabilistic forecasts by the ISOs and ensemble forecasting. And it's so important to have all of that data to see, you know, what your possibilities could look like, what your uncertainty is in your forecast. But that data is only valuable if you really understand it. So one thing I'd really love to see is the ISOs working in cooperation with the National Weather Service, because the forecasters, they've been using ensembles for years. They have a really good understanding of which models are going to perform better during winter events. When are we starting to see the models converge on a solution versus when is there still a lot of uncertainty when we're getting different model outcomes? I think AMO is actually a great example with AMO working with the Bureau of Meteorology on these forecasts, because you really do need to bring together the NWP expertise with the grid planners to use these ensembles most effectively.
Well, given that I already had my 10 to 15 minutes, I'll keep it extremely brief. One of the things I think that you know that Jim mentioned here is that it's an active demand side. The language that I keep hearing in the room here, with a few exceptions, is that we're looking at this as a supply side issue, as a supply side option, and not thinking about the fact that maintaining energy balance doesn't mean you can't move demand around. And again, that's part of the adaptive challenge that I mentioned at the very end of my remarks. And I think we need to do more of that and look at that as a way to help balance the system in many ways. And having responsive demand can cure a lot of uncertainty and risks once you get into real-time operations. On the data issue, I'm gonna quote a Jimmy Buffett song. How many of you are Jimmy Buffett fans in the room? Okay, so if you know Jimmy Buffett, there's a song called Important but Useless Information. And I worry that sometimes with the data's great, but is the data useful? Or is it just going to create more noise? And I think, you know, John was getting to that in his remarks, but I think we need to think more deeply on that.
You probably have heard enough from me, so I'll pass along here.
Well, I've got a few thoughts. Heard some from me the other day, but I did jot down a few notes around the theme of this panel, which is the barriers to achieving our clean energy goals, and leavened with what I've heard throughout the session here. So we heard a lot about short-term operations. I'm going to start there. I'm really left with the impression that we're making a lot of progress there. We're bringing a lot of tools to bear. There's a lot of data that's being thrown at the problem. We know that the inverter-based resources can be part of the solution, not just part of the problem. We're only just beginning to experience how much and how helpful batteries will be in addressing these very short-term operational issues. So I'm left with the sense that while I would never stop worrying about operations, I'm left with a strong sense that the ISOs are on the case, and they really are doing a lot to help address these challenges. Second barrier is, you heard me talk about yesterday, our clean energy markets, markets for clean energy attributes. They currently are fragmented and inefficient. Every REC broker has a book of literally hundreds of different REC products that they have to translate in between. They're not fungible. We don't really have a national market. There are active proposals to take that fragmented and inefficient situation and make it worse by really atomizing it and making everyone who wants to buy clean energy buy a bespoke, individualized product that matches their 24/7 load profile. I think that's exactly the wrong direction. Instead, we need to create a deep and liquid, commoditized national market for clean energy attributes that anybody can go and transact in with that low transaction costs, that has a long-term visible and bankable signal for the long-term value of clean energy. The third one is investment signals for resource adequacy. That's a significant problem that's getting worse. And this is, I think, the biggest use case for the big data sets that Justin and others are talking about. I think we understand a lot more now about how variable and dispatch limited resources can contribute to ensuring resource adequacy, and more importantly, or as importantly, how they should be compensated in the market. So, and capacity market reforms are now underway to help address this problem. So again, I think this is another case where the ISOs are on the case. The right things are happening. They are limited by the data, and so that is a major concern. I think about the way that we've addressed these big data and big weather problems in the past, which is for cold weather events on the gas side. We've been dealing with these big continental scale cold weather events, and we have a whole system that we've planned based around delivery and storage capability of stored energy to meet these needs. I feel like we have to just replicate that on the electric side. It's, the challenges are a little bit different in nature, but there is an example there that we should look to. And it's an especially relevant example because this sector continues to be dependent on that one for the energy that it needs to meet the electricity needs during those cold weather events. And it's going to be a long time before that's not true. We'll be dependent on stored gaseous and liquid fuels to meet electricity demands during very cold and very hot weather events for the rest of my lifetime, at least. And so we need to not be reluctant to continue to invest in that infrastructure. Getting rid of that infrastructure will be one of the last steps, not the first step on our journey of cleaning up our electricity systems. And this is all just the normal stuff that we're dealing with. Then we have wild cards, like the weather's getting more extreme than it's ever been in the past. We have a hard time building enough stuff. We're falling behind in our build rate. That's before we even get to this massive new loads that we're hearing about from electrification and from data centers. So that's maybe in a way the biggest barrier that we're facing. So I'm left with the conclusion that this is a time to be conservative when it comes to reliability. We need to give our operators more tools rather than fewer, because they're facing more uncertainties than they've ever faced in the past. That may mean being slow in retiring our existing infrastructure, because we may need it. So conservative when it comes to reliability and maybe retirements, but aggressive when it comes to investment. This isn't a time to pinch every penny and make sure that we have a benefit to cost ratio of 2.5 to 1 before we invest in a new piece of transmission infrastructure, because we just can't build. We need to build so much stuff, and we're so far behind already. We need to just go faster and faster with respect to new stuff that we need to build.
So I'm going to keep my comments fairly brief because I think there's been some tremendous vision both from this panel and throughout the entire conference this week. I am not known for being an optimistic person. I think everybody agrees with that. But we can do this. We can absolutely have a system which is decarbonized, but the risks are extreme. And I feel like we're at a fork in the railroad right now. And if we go the wrong way, then we really do have the potential for a train wreck. But we also can, like I said, we can do this, but it requires a kind of a holistic thought process to consider the whole system. Mark O'Malley said to me in 2012, I was in China. I remember the conversation while we were walking along to the subway. And he said, renewable energy is all about systems. And I was like, finally, I'm talking with somebody who really gets the big picture. And since then, I've just met more and more people who really get this. Renewable energy is all about considering, and the electric system in general, but particularly renewable energy, is all about considering how different systems interplay with each other. And they found one of the foundations to that is having the intelligence about the fuel source. And obviously, you've heard me harp on about it a lot. I'll just reiterate it once again. If we have the weather and climate intelligence, that gives us one of the pillars, just one of the pillars. It's not the be all and end all, but one of the pillars towards being able to build a reliable and flexible system. The other pillars, which we used to talk about this a lot, and I don't know whether it's just a given for people now, but the big barrier is transmission. A renewable energy system requires that you are able to move energy across large distances. We have to get this message to our policymakers, and they have to receive it. They're just not receiving it right now. If we can get interconnection, the US is uniquely placed to have a renewable energy system that works. We have a very diverse climate system where there is generally energy available. The other option is storage. Storage right now looks like a more expensive solution than transmission, but things are moving all the time. So we have to. I like the Rumsfeld stuff actually. He's not a big fan of. I'm not a big fan of his either. But the known unknowns and the unknown knowns. We need to be defining what the unknown knowns are. There are a lot of knowns out there that we can figure out, and there are a lot. And if we calculate the known unknowns, we can have a much better idea of how we can put together a system that works. And there's been a lot of talk, and Andrew's mentioned this, that we can't forecast our way completely out of uncertainty, and that is true. There will always be uncertainty. But I like to pull it up to the planning level, and we definitely cannot forecast our way out of variability. We can only plan our way out of variability. And so that's why I think it's really important that we have this weather and climate intelligence, and that's where my own particular skill set lies. So I'll leave it there and say that's one of the important pillars.
All right, so a lot of folks have already covered a lot of things I had in my notes, but trying to pick out a few kind of unique things that I heard throughout the last couple of days, and then maybe a few things that maybe I hadn't heard that maybe could be part of some of these upcoming discussions. I think a few folks have already said, we've kind of have this short-term, day ahead, hour ahead forecast operations, pretty well down from an average perspective of what happens when that error's there. We have the tools. We're kind of not really too worried about that, but the tools, or sorry, the tails are part that maybe is still kind of a focus on that short-term aspect. But also related to that, I think we kind of have had these discrete decision points for the last 20 years since the markets have been around. We kind of have this day ahead and hour, they're fairly discrete, and we sort of optimize the forecasts to those discrete time points. And as we build more storage, including long duration storage, when that comes in, I think that, and I think Paul showed this in his diagram, that some of these other timeframes become very important to forecast. Right, really forecasting, 3-4 days ahead most of the time doesn't really matter. There's not a whole lot of decisions that maybe are coming for that time point, but maybe in the future there might be more of those. Yeah, the other thing I think is just trying to think about the other inputs into our operations and planning that aren't load or renewables, that are based on meteorology. Maybe there are some other ways of improving those. So kind of looking at, the different potential timeframes, but also these different types of inputs, things like, gas demand, line ratings. We even talked a little bit about forecasting, reserve requirements, which is, function of forecasting these other things and the uncertainty based on it. So I think continuing those types of discussions would be really good. The thing sort of generally on the conference that I wanted to comment on that I think also Paul touched on is just sort of the silos piece. I think this workshop's always been really good at looking to break down those two silos around meteorology, statisticians, and sort of grid operations, market operations. And I think we, all need, and I'm, always guilty of this myself, but try to balance that in a way where we're, talking to the other group in a language that they can understand, but while also, making sure that your peers aren't, sort of bored of the information. And I think that's something to look at and see where we can do better so that we're learning more and we're all learning sort of what others are doing. I like the idea of expanding that too, and we kind of did that in a few sessions, around, how do we get distribution operations folks talking with transmission operations folks, or wholesale markets folks talking with retail, rate designers and things like that. So I think those are other silos that need to be broken. Maybe the last piece was just, we kind of said, and a few others had said that, short-term forecast, short-term operations, we sort of feel pretty good about where that's gone. The other one that's, I'm not sure if it's planning or operations, but just looking at how those, sort of short-term forecasts might evolve in the future, and studying that. And that we'll have these different types of tools in the future, different types of technologies, lots of storage, lots of renewables, more than maybe we have now, other types of, zero emission firm resources and climate impacts. And do we know, exactly, can we look at how that type of accuracy might change, what types of tools might change as part of that? So, yeah, I think most of the other things we covered, a lot of great sessions. The maybe one last thing is around the future markets that Arnie kind of touched on from some of the panels yesterday. Lots of really good ideas. I think the one thing that's really important to recognize is the length of time it takes to make some of these types of changes. And we have, in my opinion, some fairly incremental, design changes that happen, at the ISOs that, aren't, some that I know of that aren't to be implemented until 2030, that were started, began their discussions, 5 years ago or even longer. So something to keep in mind. I think also kind of looking at what the metrics are to understand, what is the quote unquote better design that is better than what we have today, and really think hard about that. So, yeah, I think I'll end there. So,
I've been coming to this conference a long time, a lot of fun. I think the thing that struck me is we were always very optimistic.
Barring me.
Barring Justin, of course. Because we were always like, hey, we're smart people. We got this. We got this. We got this. But I think the thing that struck me now is that we got this in the past because we looked at rates of change and they felt somewhat linear. Yeah, we got this. We got lots of time to figure this out. The rate of change is pretty slow. And now I'm just seeing a lot more exponential curves up on the screen. And people are commenting sometimes out loud. You hear gasps in the audience, and then the sidebar conversation is, how are we going to do this? Like, the rate of change is accelerating, and it's accelerating dramatically. It's caused by, the requirements to decarbonize quickly and things like that. I still think we got this, right? What I was really pleasantly surprised by. So I'm just going to be a pessimist. And I think the weather forecasting is probably about as good as it's going to get for a while. There's no breakthrough, and AI ML is not some breakthrough that's going to save us. And you can't predict your way. You can come up with better predictions to reduce the uncertainty, but the variability is still going to remain. What I was like awesome was the use of probabilistic forecasts by the ISOs in their planning. Wow, those presentations, absolutely amazing. The thing that scared me was all this new stuff is coming onto the grid. Large, thermal storage for industrial processes, all these data centers. So we can do what? I don't really know. But anyway, all these data centers, all these electric vehicles. And I'm just thinking, if all of this new stuff could be flexible and respond to, demand control on day one, then we got this.
Okay, a lot of interesting thoughts. So, Paul, I kind of like the conservation of risk. Now, I like your new law. We started out the meeting with Charlie, showing we're starting to validate on the 1.5 degree temperature rise. That's a little scary. There really is a risk of climate change. We're in the process of trying to move that risk onto the electric system. And, the risk on the electric system is due to the variability of the weather. The weather is going to vary. We can't stop that. But we can forecast it and we can quantify the probability. So, Pascal ended with this rapid growth in the system. We've talked about cases of outages on these extreme tail events. So have we transferred that risk of climate, or are in the process of, we certainly haven't mitigated any issues yet. Have we transferred the risk to the risk of not having reliability on our system and being doomed to more outages than we have been used to in the past? So I'm curious, what some of the panelists might think about that. How are we going to avoid risk of many outages?
I guess it's kind of directed at me. How do you get rid of the risk of outages? You don't. It's always going to be there. But I mean, the idea that we're transferring climate risk onto the power system, it's happening in different ways. I think there's one in which, because of electrification, the power system is being asked to do a lot of different things. It's being asked to become now a supplier for transportation. It's being asked to do home and building heating that it wasn't asked to do before. And that's because everybody's looking at wind and solar and other renewables as sort of the linchpin of that. That concerns me from a power systems operation and control perspective. I think Pascal said it right. If we have controllable demand from the get-go for all this load, we got this. It does make up for a multitude of sins. Absolutely. But I also think that if you look at the investment climate, and coming back to what Arnie said, I want to try to tie a lot of these comments together here, is that when I think about the data centers, I go back to all the renewables that are in the queue in every RTO in North America. How much of that's going to see the light of day? If we're lucky, 10, 15% of it. There's a lot of stuff that's, at least in PJM, that's gotten through the interconnection queue, has signed interconnection service agreements or generator interconnection agreements, whatever you'd like to call them these days, under FERC parlance, not have started construction. Why? The economics have changed. Some of it's just pure speculation, which leads me to the data center issue. I'm not as panicked about the data centers as everybody else. Charlie put up a great statistic. 108 gigawatts of data centers potentially wanting to interconnect into AEP systems across either PJM or SPP. How much of that's going to see the light of day? I bet not even 10% of that. Why? I think the issue is they're looking for a home to get tax breaks and looking where it's going to cost them less to interconnect, just like renewable energy resources do. And so I don't think that chapter is written. I think we're taking it as given, as sort of written in stone, that all that load growth from data centers and AI is going to be there. I'm not so sure, because I think they're playing the same game that everybody else is, that the renewable generators are playing on this.
Just a couple quick thoughts there. I think it's probably inevitable. I don't think it's desirable, but I think it's probably inevitable that we're going to see a degradation of the bulk system reliability compared to what we're used to in the past. And that's due to a couple reasons. One of them is sort of a more of an operational statistical reason, which is that where operators are facing conditions that are different from what they faced in the past and are just more uncertain faced in the past. So it's inevitable that they're going to run into cases where they're in a corner and they weren't prepared because they didn't know that they should be prepared because they've never have encountered that type of an event before and didn't know that they should be prepared for it. We've seen some examples like that. We talked about this example that happened in Alberta in April, where they had to shed load, not because it was super cold, but because they had a big wind over forecast and they had a bunch of units that were offline for maintenance, and then they had another unit trip, and that was enough to push them over the edge. These types of things will happen more frequently than they have in the past, just because of the law of statistics. The other big reason that I think are likely to face a degradation in reliability is because of what Paul said, the investment climate, is that we're not willing or able to build resources fast enough. We're not building the clean stuff fast enough to keep our carbon reduction or carbon emissions down, but we aren't also building firm generation. There's almost zero political will to build firm generation outside of Texas and the Southeast. Well, at the same time, we would love to be able to retire these old coal generators that are, really fouling up the climate. But we're not going to be able to do that if we're also growing loads. And even if we build a lot of wind and solar and batteries, that's only going to go so far and help us to meet resource adequacy needs. So I'm really concerned that there's a slow moving train wreck happening where there's load growth, where there's not enough stuff being built, not enough firm stuff being built. It's the first thing is that we're not going to retire the coal plants, because we're going to look around and realize that we need them for reliability. But then the second thing is the load's going to outgrow even the capability of those coal plants, and we're going to run into resource adequacy challenges.
So I actually think this is a really interesting topic, and I think it ties back to where we are culturally at this moment in time. And I think there's a division that's similar to the political divide in the country. And that the electric system is basically fundamentally changing. It's becoming like the source of almost everything that we do. And so I think this idea of flexible loads is really, really important, because I mean, how many people in this audience have children? Just quick show of hands. Okay, so a vast majority. Right. And one of the first things we teach our children is that there are consequences to the things that we do. Right. And if we have an electric system that basically is the foundation of our society and is everything that we do requires electric power. Right. There are consequences to each and everything that we do. And we're used to living in an environment where when we flick that light switch on, our lights come on and we don't worry about the consequences of that. When we stream that movie, we don't worry about the consequences. When we download that massive report, we don't worry about the consequences. We do a Google search that now takes 10 times as much power because it's using a bunch of AI stuff. We don't worry about the consequences. And at the end of the day, what really needs to happen is it comes back to that price responsive load. There needs to be a price signal so that people understand that there are consequences to their electricity use. And once you do that, yeah, we've got this. And I that's sort of what this conversation really makes me think about it. Like, we need price responsive load. There needs to be a way to send a price signal to load, that there are consequences to what it does.
Yeah, so to Justin's last point, I think the price responsiveness to load is so important. I lived in Oklahoma for 6 years when I was in grad school, and this was back in 2011, 2012. Oklahoma Gas and Electric had a program where you can get a smart thermostat. So on days when peak was really high, the price of my electricity was very high, and I could see it on my thermostat. So I knew what the price impact was if I just turned up my thermostat a few degrees. And I think we definitely need more of that, because if you just send a blanket email to everyone that says, can you please reduce your demand on the system because it's going to be really tight. But if you have no incentive for them to do that, then a lot of people aren't going to. But if you can actually tell them, here are the price consequences of using electricity during this time period, that can be really effective.
I think Justin used the word that we should all think about: cultural. Right now, we are in a cultural environment where if we ask people to reduce their demand, even if it's in response to price, we're asking them to dig out an eye. They don't want to do it as a general rule. It's a cultural thing, and we need to change the culture. I mean, I think Justin is just spot on with that. And I think the other thing too, and sometimes it requires a reframing. And so as a historian by first training, I'll just give you an analogy that maybe we should think about. It's not just the lifeblood of our economy, but the electricity system is a national security issue. Full stop. Going back to my first training. Now, how did we get the interstate highway system? Does anybody know? How did Eisenhower push that through? He pushed it through on national security grounds. It wasn't on grounds, oh, this would make things easier to travel or anything else, even though that was very true. He pushed it through on national security grounds. And I wonder, in order to change the culture, that somehow we try to reframe this, not necessarily with everyday people, but the policymakers, Congress, legislators, and say, no, this is more than just climate change. This is a national security issue, and frame it in that way that maybe we get traction. That's what I was trying to refer to. Technically, we know what to do. We're having the conversation. Technically, we know what to do here in this room. All of us do. But it's the adaptive challenge that we all struggle with, and that politicians struggle with, and everyday people struggle with. So Justin gets the award for the most important observation on this panel.
Great. This is a fabulous. Oh, I'm sorry. Do you want to add on?
Yeah, just something quick to get on to follow up on Pascal's comment about, whether or not we have this or not. I think that we could have it, but when you see that, in order to get to these 2050 goals, that we need to be building at 4 times the rate that we are now, I'm not so sure that we do have it. And I don't know what it would take in order for us to be able to get to that point where we are building at 4 times higher. Maybe it's going to have to be some big climate triggered event that finally gets people's attention and convinces people it is really something that has to happen much more quickly than it has been happening. And so I think that the speed that we need to change just isn't there at the moment.
I would argue that we've already seen the climate events. We've seen what happens. We still need to accelerate the growth, but yeah, that's a very good point.
So to go more on the pessimistic side, I think we haven't mentioned much in the conversation here. This is a global problem. It's not a US problem, not a North American problem. And certainly we, with all the resources we have and all the knowledge we have, in our community here in North America, are struggling to make progress. Now, the rest of the world, they're going to be trying to raise their standard of living and probably increase their energy use. I mean, we're increasing our energy use above already high levels, right? And yet other parts of the world at much lower are certainly striving to get to some level, some of the conveniences that we have here. So we talk about culture, and we have a cultural problem in how we view energy use, but how are we going to address the rest of the world trying to raise their view of how to use energy closer to what we have been, right? And so I fail to see how we're going to reconcile, where we are now here with what the rest of the world needs to do, and given where they are and where we are right now.
Great conversation and a lot of great insights. I do have I have another question for the panel, but we want to engage the audience as well. So if people want to come up to the mic, if you have questions for the panel, that would be great. So even aside from data centers, we're really facing exponential growth as we in load as we decarbonize the system and electrify the economy. We've seen that in many of the sessions. We're dramatically changing the generation portfolio through the decarbonization and introducing a lot of uncertainty that we're grappling with. So I heard in several sessions, several folks talk about the need to plan for a system that's operating more dynamically, to operate the system more dynamically. And I just wanted to unpack that a little bit, maybe starting with Eric and Arnie or Paul about, there's a question about dynamic reserves, which I think is a key opportunity. But what else do you see as needs and opportunities, frankly, as we look at this rapidly changing system and the uncertainty we're dealing with, and the need to be able to, the need to evolve how we're operating, perhaps different or new products. What are some of the things that are on your short list of things that are solutions that we can focus on?
Yeah, so we talked a little bit about, some of the tools that have been developed. One of the things I think from this meeting is we're not hearing, well, I guess that's not necessarily, I was going to say, we're not hearing too much of the, one time I heard one of the ISOs say that in all these stakeholder meetings, you just hear new products, new products, new products, new products, and we sort of keep implementing these, new products, new reserve types to help, as one of these types of tools. And I think that we kind of have some of those have become pretty mature. And I think the key, and already touched on this, is how do you look at the quantity of these types of services that you need both now and in the future. And we tend to only look at what those are, what those needs are now, rather than helping look at it from what a future need is. Didn't hear a whole lot this week about grid enhancing technologies and providing flexibility on the transmission system. And that, of course, in some of those different technologies have a strong linkage to, meteorology data and how that can help in providing, more availability on the transmission system. And then flexible resources, the term, that's the big, question mark, the unicorn technology, trying to figure out what that is. What are all the attributes that go into that, the Zephyr or the Defer? Are those attributes currently planned for, and are they currently incentivized? Do they need to be incentivized? Can they just come inherently because that's something that's part of the technologies? So, I feel like we have quite a lot of those tools in the operations timeframe, perhaps looking more about that flexibility on the transmission side, but looking at how those evolve, 10 years from now is something that I think is, hasn't quite been looked at too much, that is good to start playing for now. Because as I mentioned earlier, it takes a long time to get some of these things done if you see that there is a need from that time frame.
Yeah, I would say, just to repeat, I like the direction that the ISOs are generally going in this area, using all the data that's out there that's now available to them to help them better prepare their grid for whatever might come their way on an operational timescale. The CAISO kind of started this with their flexible ramping product that they implemented in the Western Energy Imbalance Market. It's not a market product yet, but I think it probably needs to go in that direction. There's no reason why that couldn't be procured competitively and recovered through the market operations. They're now expanding that product to be a day ahead product, where they look over the next 24 hours and understand how much headroom and footroom that need to address day of operational conditions. That I think also could be a formal reserve product that's cleared through the market. The 2 week ahead thing that New England are doing, I think is going to be useful for them to help understand maintenance decisions and fuel procurement and other things like that, just to send information to the market to help, again, just get everyone ready for the operational day and what might happen. I guess beyond that, I would go back to what I think Justin and a couple of others have mentioned, is just the more that we can get the loads to be dynamically interacting with what's happening in real time on work the supply side resources will have to do, with less investment that will require. I'm optimistic there because we have loads that are going to be more flexible than ever. Electric vehicle type of loads. I think some of the data center loads can be more flexible, and we now have IT and information communications technology that can make a lot of this response much more automated than we have seen in the past. Prices to devices kind of things. So I think that stuff is going to happen, and that's going to be a big help.
Now, at the risk of sounding like a heretic, I don't think we need all the transmission that everybody's saying we need. And I'll give you a cautionary tale. Alberta. Alberta has a no congestion policy currently, and it's had since 2004. They have so incredibly overbuilt their transmission system just for that. And then their interconnection policy, it just pays for shallow interconnection charges, and then the load pays for the transmission otherwise to make it deliverable. Or now defecting from the transmission system. I think we're actually starting to see a little bit of that with these large loads, data centers, crypto mining, co-locating with generation. Savings there by not having to pay for transmission. So I think we need to be careful what we wish for. So that really pessimistic note, I have some optimism though. And one thing that hasn't been mentioned on this panel, and I haven't mentioned it yet, is distributed energy resources. Distributed energy resources can make up for a lot of possible needs for the transmission build out, especially if you have solar or something on site to generate combined with storage, whatever vendor you want to look at, along with the idea that maybe if we have energy efficiency, we really do stuff. And I wish Eric's house would be a case study on this new house, this sort of passive house would be a great case study on this. You start doing that, and then all of a sudden the energy needs kind of go down, and then that makes it all a lot more possible. And so we're not thinking through all the things yet. So I'll be pessimistic on transmission, but optimistic that the solution could rely on DERs as well. But it's not the silver bullet, but it's just another tool in the toolbox.
Annoyingly, you just beat me to the punch because that was the exact point I was going to make. Yeah, I very much feel like something that hasn't been talked about enough over the last few days is leveraging DERs, distributed energy resources. It is easy to say from an Australian perspective because we have so much DPV, but what we don't really have is behind the meter batteries and storage. It's not really penetrated in material manner just yet. And also to kind of just echo some of the other points is, having that coordination with, market design, systems planning. We're working really, really closely with market designs teams to try to come up with market products and tools that can really address how to leverage that. So one of that being like flexible export limits, another one being actually having this kind of orchestrated effort to turn distributed energy resources into scheduled contributors into the network. So there is a lot that we can do actually leveraging and utilizing existing sources of generation. And obviously we still need to build things out, but that takes a lot of time, but we already seeing a lot of growth in DERs. And I think there's a lot that we can do there. And I just had one other point, but it's a mistake, and maybe I'll come back to it.
I think on that point, there are so many cool things we can do with electric vehicles, but we need to make it, cost effective for people to buy them. And we need to make sure people have places to charge them, because we could have like batteries sitting in like every garage throughout a city, and they could be used as batteries, but only if we can get the electric vehicles out there and make them usable to people.
This is a really fascinating topic that we just hit on. And as Paul was talking, I was like, yeah, but Paul, what when it's cloudy for 5 days? How does your distributed energy system work for you then? But then and Andrew and Andrew then started talking about behind the meter storage. And this brings us back to that culture thing, right? So I think, unfortunately, we're sort of divided largely into like, oh, renewables aren't going to work. Climate change isn't real. And then people are like, renewables have to work because climate change is real. But the bottom line is if we don't do it right, renewables won't work. But if we don't do it right, the fossil fuel grid won't work either. But bringing it back to the cultural side and the personal responsibility and the understand by having distributed energy resources and by having batteries, those days when you're getting into a situation where there's a solar drought, for instance, we're expecting days and days of cloudy weather and it's extremely cold and everything else. That's the mindset should almost feels to me like it should be the same as when we know we're preparing for a snowstorm. We go out and we buy a little bit of extra food. We go out and we do this, that, and the other. So you make sure your car's charged, you make sure your batteries are charged, and that way we can alleviate the strain on the grid and just having that sort of sense that we're all in this together. And that's kind of, it feels to me like, you know, it's the solution is more at a higher societal level than at the technical level.
Well, that issue reminds me of my interaction with the Hawaiian Electric Light Company on the Big Island. And there were, because of the high cost of power there, a lot of people who were essentially off-grid, battery system and a PV system. And you didn't see the load, right, because they were off-grid. But after 3 or 4 cloudy days, right, batteries were depleted and they had to come back on the grid. And all of a sudden you had this unexpected load showing up. So it basically forced the grid system into carrying the capacity to handle that wasn't there most of the time. So you were back in the same position, sure. If everything was going well and you're able to go through the daily cycles charging the battery, those loads never appeared on the grid. And then all of a sudden you ran into a situation where now all these loads were appearing because you weren't able to maintain the battery charge for that period of time. So yeah, then the grid had to carry a lot of capacity that it would rarely use, which is often, you know, where we are with the grid. But so it didn't really help in some sense, even though day to day, certainly the loads were lower.